Okay. It's always awkward to, yeah, okay, modules. Just trying to figure out how far I have to scroll down. Okay. Exam 3 review. Right? Yeah, because that's the exam they're on. Yeah. All right. So you guys didn't go over problem 5 from last session, did you? On the exam 3 review? Does everybody have access to the exam 3 review? We'll just wait on that. By the way, do you have a pencil that I can borrow? Another green one. Let's see. 5. Oh. Okay. So I'm gonna just start writing up problem 5. It was not in the previous session, so if we could go over that, that would be cool. Okay. Let me go through the notes real quick. Report. Oh, they wrote quite a bit. All right. So here's some notes from the last section. I'll go over these real quick, and then I can get into some practice problems. I'll try to use ones that are slightly different from the first set for review. All right. So going over kind of exam contents. So we have geometric series. So this will follow a clear rate of change, which, well, not really a rate, a ratio between each number in the series. So like if we had the series 1 to 4, we're clearly doubling each one because this is times 2 times 2. So then I go 8, so on and so on. What we know is that if R is less than 1, or the absolute value of R specifically is less than 1, then we have a converging series. And we can use this in order to find the sum, where A is your initial value, and then you do 1 minus R, which R is the ratio between each number. So in this case, it doesn't really work. If I were to change it to 1/2, 1/4, 1/8, whoops, I was thinking of 8 and decided to write 8 instead. So this series plus dot, dot, dot. What we would do is we would know that the rate is equal to 1/2, or the ratio is equal to 1/2, because we take, so you do your n plus 1 term, so a of n plus 1 over a of n, so 1/8 over 1/4. Flip this, you get 4 over 8, which simplifies to 1/2. So our first term is 1, so we get a equals 1, and then we use s right there and get s is equal to 1 over 1 minus 1/2, which is equal to, so this is 1/2, so that would be 1 over 1/2, which is equal to 2. So that's geometric series. So ratio test, kind of went over it right here. Take a sub n, or a sub n plus 1 over a sub n, compare it. So yeah, and let's see. Okay, so for the comment, S is the sum. Yep. All right. So power series, or anybody have any questions on the ratio test? Should probably make sure that it's always a little awkward. So no questions on ratio tests. So power series. So let's see. I might need to actually review that myself real quick. I know they have power series right before Taylor and McLaren, right? Yeah. So yeah, this you tend to, yeah, I remember this now. So you use an equation that you've learned before. So power series, one thing that you'll kind of like want to remember is this 1 over 1 minus x. We can relate to a summation that looks like this: 1 plus x squared plus x cubed plus, I think you get the point. Or we can say it's equal to the summation of x to the n. That'd be to infinity, and then n equals 0 for the start because we start at 1. So from here, using this identity, we can kind of manipulate it in a lot of ways. So one thing we can do is, let's say that we multiplied this value by x. So we have now x over 1 minus x. Well, if we look at this, we can simply say, well, all of the powers will increase by 1. So now we have x plus x squared plus x cubed plus yada, yada, yada. So if we were to rewrite this summation, there are a couple of ways we can go about it. So if we wanted to keep the same bounds, which is probably the easiest, we just say n equals 0 to infinity. And then we have x to the n plus 1 because we have, it would be this times x. And you would just add the exponents together, so n plus 1. Then there are weirder versions where, let's say we have, natural log of 1 minus x. So this gets weird. So this, if you know your integral terms really well, or integral rules really well, you'll know that the derivative of this is 1 over 1 minus x. So that means the integral of 1 over 1 minus x is equal to that. So now we have to think, okay, what if we integrate all of these terms? This is where it starts getting a little weird. So if we integrate each term, now we get x, then this will be x squared over 2. I guess, do I need to take care of a negative? I think I do need to take care of a negative. Yeah. Ooh. Does that make everything negative? It would be just that, right? Yeah. So negative natural log of 1 minus x. So yeah, from here, is there enough? Yeah, okay. Sorry. So this goes over 2. Because again, we integrated this, so we just integrate this side. So then we get plus x cubed over 3, and then plus x to the 4th over 4. So that one gets a little weirder. Now we have to use some separate rules. So what we notice is, so we can technically say that this is 1. So we're going 1, 2, 3, 4. So we can say that this summation, so negative natural log 1 minus x is equal to the summation. Again, we always start off with n equals 0. And then going to infinity. So now we start off with x, so we know that we have x to the n plus 1. And then it's always over n, because our first term is over 1, second term over 2. So that's power series. We can go more in depth, but that will take up a lot of time for the rest of the review. But this is just to kind of help you guys see. It's just kind of manipulating it. Another way that you can manipulate it is changing this x for x cubed. And that you would replace every x in here with x cubed. Or if you're looking at the series directly, you would just replace every x in here with x cubed. So it would just be x to the 3n. Because this would be, so this would still be 1. This would be to the 3rd power. This would be to the 6th power. And then this would be to the 9th power. So yeah. So it's really just remembering the initial pattern of 1 over 1 minus x, and then knowing what manipulation you did to get to the next part, and then applying it to your series. So Taylor's series hopefully is pretty fresh in your mind. It really does help to make a table. You would take your derivatives, and then you could also do the other parts of it because you have a factorial, which can be a little annoying. Yeah, you just go through, write all the values down, and then combine them all together. And then applications of Taylor's series, so approximation. So we don't always go out to an infinite number of Taylor series. We typically go to like 6 or 5 terms. So knowing approximation and then estimated accuracy using that. So now I guess we can get into an example. So I'm gonna start us off with, I think 5 would be a good one. Yeah. Find the sum of the series for those values x. Okay. All right. So I'm gonna get a new page out. Let's see. Trying to find a blank one. There's a blank one. Okay. All right. So number 5, exam 3 review.
Somebody else's example for me to get from.
Oh, hopefully your Canvas course has it. It's the, yeah, practice exam on WebAssign. I should probably pull that up too. This one's being pulled from the exam 3 review PDF on MA 2160 R02 if you're in that group. I was going to write them all down. I don't remember the WebAssign. Do you want to log on to that while I do this problem? So, all right. So we're going to, for here, we're going to find values of x where the series converges. I'm going to do that real quick. This is a little warm up, and then I can move on to that if everybody has access to the WebAssign. Practice exam P5, maybe? Yeah. All right. Let me just check what 5 is on here. Okay. So yeah, I'm going to quickly go over this example on just a separate thing. I'm just going to go over a couple of them because there's like A through F on this. So if we have, so start it off easy. So if we have the summation of -5 to the n, and then x to the n, what values would we need in order to make this converge? This would be n equals 1 to infinity. So one nice way of doing this is always to combine stuff. So if we go here, we can combine the -5 and the x all into one term. And then because they're both to the nth power, we can just do that real quick. So that's one thing we can do. So now we do our ratio test. This again is n1 to infinity. So we're going to do a sub n plus 1 over a sub n. So we get -5x to the n plus 1 over -5x to the n. So we simply simplify. So that's, or we have to the n power here, we have to the n plus 1. So we just get rid of that n. Now we just have -5x. And we need the absolute value of -5x to be less than 1. So with that, we just take, okay, -5x. So we would technically do this. So -5x has to be this. And then we divide both sides by -5. And when you divide by a negative, you flip these signs. So this becomes 1/5, because positive, or negative makes positive, greater than x. And then this would be flipped. So x has to be greater than -1/5. So we know our, basically our x values is going to be from -1/5 to 1/5. And then from here, you can check whether one of these is included. What I simply do is I just plug them in right away. So if we plug in +1/5 to here, we will have -1 to the n. So if we were to sum that, we would get -1 plus 1 minus 1 plus 1 minus 1 plus 1. I think you get the point. It's going to constantly be switching between 1 and 0 for the sum. So it never converges. It just hops between these two as n increases. Because that cancels, and then those two would cancel at this point. But if I keep going on, it would be, I guess it would be -1 or 0, yeah. Now, if I plug in -1/5, now I get -5 times -1/5, which is +1. So we would get 1 plus 1 plus 1. So that definitely doesn't converge. So that's just a quick ratio test. If we were to do a slightly harder one. Yeah, find the sum of the series for those values of x. Can I really do that? But yeah, let's see, what's another good one? I'm gonna do C. So this would be part C. After this, I'm gonna move on to the web assign. This is just kind of a warm up. So if we have the summation of, so x minus 2 to the n over 3 to the n. So this slightly harder one. And that's going to be from n equals 1 to infinity again. So I use a ratio test. So there are two ways you can do this, whichever, or two ways that you can really write this, whichever way you prefer. I prefer this way. So This is our n plus 1, because again, we're using that bit right there, over 3 to the n plus 1. And then I just draw my fractions on top of each other because I'm weird. So there, and then 3 to the n. So now I can simplify, though I don't simplify like these two or these two. I simplify this with this, this with this. So we have n plus 1 here, n here, that cancels, get left with that. N here, n plus 1 there, cancels, left with 3. So you get x minus 2 over 3. But we need to show where this is less than 1. So we get x minus 2 over 3 is less than -1 and 1. Multiply by 3. You get -3 is less than x minus 2, which is less than 3. And then we just add 2 on all sides. And that gives us, so -1 is less than x, which is less than 5. And that's where we converge. Oops, keep knocking it around. So we get x, -1, 5. And if we were to plug in each number, so this is kind of where it becomes more important to actually plug in numbers. So if we were to plug in 5 to here, we would get, so, all right. So 5 minus 2 is 3. So we have 3 to the n over 3 to the n. So we would just get 1 to the n, or really just 1. So we'd just be summing 1 an infinite number of times. Clearly that doesn't converge. Now, if we were to have, wait a minute. Yeah, so if we were to have -1, however, so -1, oh wait, never mind. -1 makes it -3 to the n over 3 to the n. So this would simplify to -1 to the n. And that, again, would be the same as this case. So yeah, neither converge again. So we would just not include them. Why did I think that they converged? I did mental gymnastics, but all right. So with that warm up, now we can move on to WebAssign. So let's see. I'm gonna, is there any questions that people really want answered for practice exam 3v5? Anybody? If not, I'll probably do number 6 on the practice exam. Number 11, okay. We'll go to number 11 first then. All right. Let me flip the chat real quick. I want to make the chat visible for me. There might be a way to get access to that PDF. Your exam's on Wednesday, right? I believe that's when it is. Yeah, we can see if that PDF can get handed out. I don't know if you want to send an email or something. Yeah, ask Jacob if you can send an email through. I think that would work. We'll try to get that to you somehow. So number 11. So we have the following function. So I actually might just use a page for this because it's going to be a bit. All right. So number 11, and this is WebAssign. exam3, that would be 5, right? I think it's exam3, and I think it uses Roman numerals for the version. So exam3 and then IB. So we are given the function f of x is equal to x to the 7th power. And then we know a is equal to 1, so that's where we're centering around. N is equal to 3. So that's the number of terms we're going to. And then we have x 1.1 and 0.9. Okay. All right. Oh, it bothers me that the key is in reverse. That bothers me to no end. Okay, so formula for a Taylor series is going to be summation, and this is going to be from n equals, do you go 0 first or 1? Wait, I can easily do this. We do go 0 first, yep. All right, and then we have f. This is a weird notation. You have a n in parentheses up to represent what derivative you're on. A, and then times. Wait, whoops. I was going to say a minus x. It's x minus a. X minus a, and all over n factorial. All right. So we need to know what our function or what our derivative is each time. So I just quickly do, and we want to evaluate it at a. So
where did you get that form from?
this formula from?
Yeah.
Well, that is actually pulled from my head right now, so maybe I should check to make sure it's right. That's just how I've always written it.
In general, though, is it in the chapter or is it?
Okay, if you go to page 761, so section 11.10, you can find something that's quite similar. Actually, I'll show it.
It's also on the review sheet that Joy sent out for the like the final exam or the exam like sheet that you'll be given during the exam.
Yeah. Is it on there? I forgot to pull that one up. Let's see. No longer using that, so I gotta scroll back up. Exam 1, exam 2, exam 3. Yeah, the formula sheet should contain it, I think. Do they have it here? Yeah, they have, yeah, so if you see here, they have this exact formula written there. So it's the same as what I wrote. I just, I like to put this on top because I like to make my fractions just, well, if I have a fraction, I just combine everything. So same formula that you'll be given.
Okay, thank you. I get it now. Yep.
So since we have n equals 0, we have to start at f 0, which is just the function itself. So we would just plug 1 into here. We get 1. And you'll find that it's going to be quite similar. So actually, I guess it's always good to start with just writing out all of the equations that we don't have to go back and forth. So this is going to just be x to the 2 over 7 Then we have f single prime, because now n is equal to 1. So that will be equal to 2/7. And then we have x to the negative 5/7. That's right. That's just by subtracting 7/7 from that. So 5/7. So next, and it's going to get ugly real quick, which is why they only have you do 3 terms. I think should probably close that. Yeah, they fixed it to n equals 3. Okay. So now f double prime. Now we multiply this by negative 5/7. So we get negative 10/49. X to the negative 12/7. Now we got to multiply again. So we take f triple prime. So that would be positive 120/343 x to the negative 19/7. Luckily, so you'll notice that the denominator, you're just going to be taking the powers of it every time. So 7 squared, 7 cubed. So that can help you kind of save some time. So now plugging in 1, luckily, all of these kind of cancel and they just turn into 1 because 1 to any power is still 1. So we already know f of 1 is going to equal 1. F prime of 1 is going to equal to 2/7. F double prime of 1 is going to be equal to negative 10/49. And f triple prime of 1 is going to be equal to 120/343. So now we just plug in all of that to our series. So this is going to be t n equals 3 of x. So here we're going to start with n equals 1 or n equals 0. So we have 1. So this would be to the 0 power, so that's also 1. And then so 0 factorial is also just 1. I don't remember the exact proof for why that is, but just remember that. So we have 1 times 1 all over 1. So we get 1. And then we add for n equals 1. So now it's f prime, so 2/7. So we'll have 2. I'm going to save the bottom part for when I'm writing that. Times, and now it's going to be x minus 1 to the first power all over. So now it's 7 times 1 factorial, which is 7. Next, we go to the second power. So now we have negative 10/49. Not a fun one. So we have minus 10. Again, I'm going to save to move it on the bottom. This is just nice for keeping your work nice and neat. So now it's 49. So this was 0 factorial, 1 factorial, 2 factorial. So we take 2 times 49, which would be 98. Yeah. Notice we have the minus there already, so don't have to worry about that. And then we have 120/343, not a fun one. I don't really want to multiply that by 6 in my head. All right, so now we have plus 120 times x minus 1 cubed all over. Oh yeah, that is a way. So just remember the trick. So this would be 3 factorial, which is 6. We can just take the 6 out of here real quick. So 120 divided by 6 happens to be 20. And get that. So this, of course, you'd have, depending on the person, you could have more work unless you did all the calculations on a calculator and just wrote it out like that. But this is just a simplified version. I don't know how much of a stickler they are on the simplification.
I don't know, what you feel.
Yeah, there are a lot of numbers in this, so just whatever you feel comfortable with. Yeah, so this would be, so that would be for part A right there. And again, it's all dependent on what numbers you have. So if this was like 3/7, we have a similar denominator, but our top portion would be slightly different. But if you had like 2/5, then that would change. Yeah, so now use Taylor's inequality to estimate the accuracy of the approximation when X lies in the given interval. Okay. Do you remember how to do this really well? You want to swap for a little bit?
I'm just sending these emails to the PDF.
Oh, you are? Okay, then I won't make you.
Okay. Yeah, sorry, I was just talking to Jacob a little
For
bit.
that. Okay, so for when we're finding the error, we always look at the next term. So just past where we're at. So we have to find, yeah. So we follow this. So for R, so this is going to be kind of your error. So for R3, or I guess I can just say Rn. So Rn of X is going to be less than or equal to, this is going to be, so M, then over N factorial. I never understood why they write it like this. And then X minus A to the, oh wait, I just realized that's N plus 1 factorial. Never understood why they write it the way that they do, because I feel like adding the M just confuses people. Because most of the questions we get in the math learning center is, how do I find M? Well, you might recognize this and this from here in the equation. M happens to be this in the equation. Just we rewrite M as f to the n plus 1, because if we're looking at the third term and we're finding the error, we have to look at the fourth term in order to determine it, which we don't have yet. And this again is A. So again, never understand why they write it out like this, because why write M when they already have seen this? This is free, this is to help you. So always remember, it's just the same formulas as this, but n plus 1 and an absolute value, but that doesn't really matter too much. Okay, so let's see. Yeah. All right. So for our case, we should probably find M real quick. So we have R3 of X. And so we need to take the fourth derivative. So this would be, all right. Ooh, that is very much not fun numbers to multiply. So I'm going to cheat and just write it all out. So f of X is going to be equal to, so now we have negative 120 times 19. And over, so this would be 1, 0, 3. I think that's right. I think that's 7 to the 4th. I'm gonna cheat. 49 times 49. How did I mess that up? I messed that up real bad. Don't know how I messed that up. Okay, I know all the rest of that's correct. So, okay. And then that would be times x to the negative 26 over 7ths. So I guess I could just do 120 times 19 real quick. Why would I bother doing that? Okay, 120 times 19. Negative 2280. All right. I know, I messed that up. Okay. So got negative 2280 over 2401. When we plug in a equals 1, of course, it's going to just be this fraction right here. So we get negative 2280 over, and it's going to be, do you take the absolute? Yeah, that's right. M is the absolute value of this. So again, this is really just taking absolute values everywhere. And the reason why we take an absolute value is because a negative error or a positive error is still just some difference from the actual term. So we just consider it an absolute. So M in this case would be positive 2280 over 2401, and then it's times 4 factorial. So that'd be 4 times 3, which is 12, times 2, which is 24. And then, so x. So our x is ranging from 0.9 to 1.1. Whoops, let me put that down a little bit. So our x is ranging from 0.9 to 1.1, and a is 1. So if we have 1.1 minus 1, we get 0.1. If we have 0.9 minus 1, we have negative 0.1. Since it's the absolute value, we just have 0.1 here, and then it's to the 4th power. So if you combine all of that together, you get your error, which in this case should be approximately 0.12345, and then 585. So that would be our error. Any questions about that? Did I miss any questions when people are handing out their emails?
Yeah.
Nope.
Do you ever saw an answer sheet for that PDF?
Let me see. That's the formula sheet. Do we have it? Practice exam solutions. I don't know if that's actually it though. I think it might be.
Just go for one of the problems.
Yes, it could be found as the maximum value within the interval. So typically, if you have like a cosine, you always assume the 1 or negative 1. Let me check to make sure I did that right then, because I might have skipped over a bit in the solution. Oh, where is the? Yeah. Yeah, we're looking for that. I think this is it. I think it's practice exam solutions, Carly.
But this wouldn't go over every problem.
I
Just in one of
think
these.
it does.
Oh, like all
Fine.
the parts they gave through kind of doing.
Yeah, I think they just use different numbers.
Oh, okay.
Yep.
Okay, I'll send it over with that.
Or they at least go over one part for each question, I think. It's still useful. So
Yeah.
yeah.
Okay.
Yeah, and the x minus 1 would be the max, where the max occurs. Maybe. I think you just, okay. Oh, yeah. So actually, yeah, never mind. You do find on this interval, so from 0.9 to 1.1, you do find where it maximizes at. So for this equation, as x increases, this decreases in magnitude, I believe. Yeah, which makes sense because since it's a negative exponent, the magnitude would decrease due to the number getting larger, therefore you're dividing by a larger number. So we know that it's 0.9 is the largest interval. So then you actually would plug, so you would actually, for this, it would be, so that's actually x, not a. So our m in this case would be equal to 2280 over 2401. And then it would be times, so 0.9 to negative 26 over 7. So we would actually have that whole thing in. Yeah. So this is still the correct answer for these numbers. I just was rushing without realizing it. So yeah, so this would be slightly different. So the times are 0.9. And then times 0.1 to the fourth. So that whole thing. And that gives us our error. Basically, the reason why we just use our n plus 1 for here is because we've already included all of these terms. And due to basically the increasing size of the denominator, we're always going to end up having like really small numbers beyond this. So we can assume that the next number would be like the largest possible error for this. That's like a very watered down version of the explanation. So any other problems that you want to go off or go on? I can do, so that was the last one. Let's see.
If there's anyone who didn't put their email in the chat that wants those PDFs, please do so now. I think everybody else should have gotten an email with the 2 documents.
Okay, one person. Oh, so why did you multiply 0.1 to the fourth? Isn't the interval from 0.9 to 1.1? So because our maximum value is at, whoops, let me just, so since our maximum value is at 0.9, so our x will be equal to 0.9 for this error. So we plug in 0.9 here, a is 1. So we have 0.9 minus 1, which is negative 0.1. Take the absolute value of that. And then we have n plus 1 power, which is so to the fourth. So that comes from this right here by plugging in 0.9 minus 1.1. All right. Any other questions about this? If not, any other questions that you want me to go over? And if you have like a practice exam version, so just tell me the version that you want and then what number. I'm currently on version 5. I can switch to whichever one though. Actually, I might look up some good examples that, well, we can always go over. Number 1, okay, I'm gonna just assume that version 5 is still fine. All right. So number 1, again, this is, let me that up. So this is, again, exam 3. Why did I say that's version 5? I know my Roman numerals. I am. Okay, version 5. All right, so we have a sub n is equal to, and this is a sequence, so we're not looking at a sum. This would be -1 to the n minus 1, and over 5 to the n. All right, so the first number in the sequence will be at n equals 1. So you just automatically assume that will be n equals 1. There's no 0 term of the sequence, I guess is what they're getting at. Unless you're a computer science major, when you always start counting at 0, but except in MATLAB, that's the number 1 complaint I hear. So, so we're solving a, oh yeah, actually, the question even lays out what's A1, what's A2, what's A3, A4, and A5. So A1, we just plug in 1. So you get -1 to the, so 1 minus 1, which is 0. Anything to the 0th power, including 0, is 1. So we have 1, and then 5 to the first power is going to be just 5. So we have 1/5. And then here, now we have, so 2 minus 1, so -1 to the first power. So we'll have a -1 on top, 5 squared. And you'll notice quickly that this is just going to change between negative and positive. So now we have positive 5 cubed. Sorry, I didn't space these out well enough. This will be negative. And then that would be 5 to the 4th. And then this is positive. I could keep going because I know my powers of 5 really well, but that's another story. So that's how you would do that. So it looks like the only number that changes is this right here. So you'll just go positive, negative, positive, negative, positive. Any questions on that? No? Don't believe so. Could go over to. And quickly going over, so this is a sequence. So it's important to remember the difference between a sequence and a series. Can we do find a formula equation? If I find a good one, yeah, I'll look for that. If anybody finds one while I'm going over this, feel free to let me know. So sequence, so this is just a list of numbers. So list of numbers. So we would have i.e. so 1, 2, 3. So the main difference is commas rather than addition. And series would be this. This is a series. So series entails we're adding terms. Of course, this is subtracting, but subtracting is just adding a negative. So it's a light lesson. So remember, the convergence of a sequence just needs one of these terms to converge down to some value, whereas convergence of a series needs the entire sum to converge. All right. Let's see. Do I have a good one? By finding a formula, you mean like finding the summation, right? Like finding, I guess. So are we trying to find the inside of one of these based on a series that we know? So like plus x squared plus x cubed, or yes, in this case, so that it actually works. So messed up. So like that would just be x to the 2n, starting at n equals 0 and going to infinity. Is that what you're looking for? Something like that? Because I can look for if they have an example. Oh, yeah, like use Maclaurin series for, so number 8, I think would be a good one. Yeah, okay. Gonna get a new sheet for this. All right, so this will be number 8. Oh, I'm gonna have to rush this. All right, so number 8, because we are nearing time. So this is exam 3, 5. All right, so we're given a function, and it's x cosine 9x. There, yeah, x cosine of 9x. We're trying to find what the summation is. So equals summation of what? All right, so the quick way of doing this, kind of similar to power series, is we know, so cosine of x, which you probably have like some note on this, is always equal to, and that would be -1 to the n and times x to the 2n. That's because it kind of skips due to the nature of cosine and sine. And this is all centered around 0. So, and then 2n factorial. All right, so use that real quick. So now what we do is we say, okay, well, this is cosine, but multiplied by x, and all of our x's originally in here are substituted with 9x. So using that, we can quickly say, so this would be from 0 to infinity, right? Yeah. So we can say x cosine of 9x would be this. So we would take our summation, and after this, I think we're going to have to get going because we are running out of time. Whoops, 0. So first, what I like to do is substitute all my x's real quick so I don't confuse it when I multiply that through. So, so this unaffected, -1 to the n. Don't have to worry about that. This is going to be affected. So we have now instead of x to the 2n, we can separate it as 9 to the 2n times x to the 2n, then all over 2n factorial. So that's just dealing with that part right there. And then we multiply an x in. So if we multiply this term by x, we just add +1. You could also choose to write it as, so you can write this portion right here and write it as 9x to the 2n and then multiply on the outside by x, whichever suits you. I like to do it this way just so that I easily separate everything out. But yeah, so I guess last thing to just go over this real quick. So whenever you have a problem where you're given a function and you're trying to find the series that describes it, it really helps to use something that's a baseline like this. And then add in terms, so like, since the inside of the function 9x, or is 9x instead of x, we replace all the x's first with 9x, and we get that portion right there. Then the outside, we just multiply that through. So that's the crash course on how to do those problems. They can get a little more complicated, but normally you just quickly find what's the base of it, and then you add on from there. Any last minute questions that are brief? If not, I'll be shutting down for the night. The recording should be available on YouTube sometime in the near future.
Yeah, probably by tomorrow.
Probably by tomorrow. We'd hope that it gets done that fast, because you guys have an exam coming up. If you want to review it. So yeah. Hopefully everybody got the PDFs that we emailed out. Feel free to share those with your friends if you or if they were not able to come. So yeah. Any questions? No? Start shutting down. Looks like people are leaving.
Great. Have a good night, everybody.
I'm gonna end the meeting now. So, all right, you might.